Hello folks, Sebastian Sonica here. In today's video, we'll troubleshoot and fix a loader error using WinDbg and System Informer. Let me first show you the error. So that's the faulty application, and when I try to run it, we can see an error message box coming from the loader. And the message box tells us that there is a problem with an import of the string copy function. Unfortunately, the message box does not tell us from which DLL our application tries to import this function. But that's actually easy to find either in loader logs or in a PE viewer such as PE or a viewer available in System Informer. Let's first have a look at loader logs or snaps. We enable them through image file execution options in the registry. But there is a GUI tool called gflags that makes this easy. And we will use gflags to configure the loader snaps for executable. So let me start gflags or global flags for the 64-bit. I need to run them as administrator because we'll be modifying the Windows registry. Let's close the message box, and then we need to go to image file, then type our executable name, then tab, and check show loader snaps, then apply. And those loader logs or snaps, they will appear in the debug output. So we need to attach a debugger or run our application under a debugger. So let's do that. I go to launch executable advanced, and here's the path to my application. And now when I try to run it, you will see that there are a lot of new messages appearing in the debug output. And we can look for this problematic function in those loader snaps. So here it goes. We can see that first there was a warning that procedure could not be located in a DLL at base, and that's the base of the DLL which we are looking for. And then there is the final error which says that the locating export failed with status, and here's the error code. So let's look for this base address, and we can see, actually, I might close this one and go back. So we can see that the DLL from which we try to import this function is shell32DLL. So this function is probably missing in the export of the shell32DLL. We can also verify that we have this import in our executable by using the PE viewer available in System Informer, or formerly it was Process Hacker. I still sometimes use this name. So let me double click not conhost but the app.exe. Here we can double click on a module, then we can go to imports, and here is our import from shell32 DLL string copy and W. By looking at the relative virtual address, we can see that it belongs to a directory named import address table. So if we go to directories in the PE file, we can see that the range, this range of addresses, virtual, not raw, but virtual address, relative virtual address, we can see that the address that we saw in the imports belongs to this section. This information, I mean this relative virtual address, will be very helpful for us because that's the address we are going to modify to make the application work. But to modify this address and avoid the error that we saw, we need to stop very early in the process launch. And normally, the first moment when the debugger stops when we launch an application under a debugger is the initial breakpoint. But that's too late. We saw that the message box was already shown before our actual break in the application. So it must be earlier. And the earlier event is the create process event, which normally is ignored. And that's the default configuration, and we will enable it. So let me run sxe cpr, and then we'll restart our debug session. Now we are stopped very early. NTDLL has not even loaded. We can list the modules and we can see that only our executable was loaded into the memory. And that's the perfect place where we can make any changes to the import table. Of course, here we will be dealing with unresolved addresses. So what we will see at this address, let me bring back the System Informer window. So what we'll see at this address will be also a relative virtual address that will point to the place where information about this import are stored. And we can check that. So let's display this address. Let me copy that. And as it's a 64-bit application, and the image model tanks have 64 bits, so 8 bytes, and we need to use a dq command to show them. And I will use the relative address that I copied, and here we go. So here's the relative address which stores information about a given import. So this address will be later resolved by the loader to the actual physical address. We can see what's there. So I will use db this time. I will print all the bytes, and we can see that the first 2 bytes are something called hint, and then goes the actual procedure function name in ASCII. So that's how import by name works. So that's the import by name structure in the PE file. But as we know that this is the problematic import, we are going to modify this address to avoid the problem. What we will do, as we only have one import coming from shell32 DLL, we can actually simply set it to 0, and then the loader will probably completely skip the shell32 DLL. And we will stop in the initial breakpoint, so the moment when the loader finished resolving, but the application hasn't yet started. And that's also a perfect place for us to fix this address. So instead of using shell32, we should switch to shell w API DLL, where this function currently is located. And I haven't mentioned about that, but this error is actually quite common in legacy applications. In the past, this function was defined in shell32. Now it's not now, but from some time it's in shell API DLL. So let's zero this import. So instead of using dq, we will use eq, and then we'll set it to 0. So if I run dq again, we can see that we zeroed this import, and if I run g, you can see that there was no message box. So the loader finished the first phase of resolving the addresses, and we broke into the debugger. So we are now at the place where we can mess with this address more, so we can actually perform some additional actions. First, we need to import the shell WAPI DLL, so the one which contains this string copy function. And that's the hardest part. I prepared a little script that you can find in the debug recipes repository in the WinDbg field notes section. There is the inject a DLL into a process being debugged, and here are the steps how you can do that. Let's go through them, and I will explain them. One extension that we'll be using is the SymBuilder composition DLL. That's one of the samples available in the WinDbg samples repository. But before we use it, we need to learn what's the address, the relative address of the load library w function. So that's the function that we'll use to inject the DLL into our remote process, so the debugging. So let me run this command. So that's our offset, and it should be the same as I saved here. So that's the same hex value, as you can see. Next step, we are going to load the DLL. You can find it in the WinDbg samples, as I said, and you need to build it. That's the folder where I store my extensions for WinDbg, and after I load it, we now can use the commands that it provides. And one of the very important commands is that we can create symbols for any DLL. So the problem with the original symbols from kernel base are that they are public symbols, so they do not provide information about function parameters. And we are going to use a command from WinDbg named .call. That's a meta command. And we are going to call this command with an address in the remote process, so in our target process, that will contain the name of the DLL that we want to load. In our case, that would be this shell WAPI DLL. So let's perform those steps, the next steps. So these steps are described in the documentation of the symbol builder composition. So we are going to create a symbol object for kernel-based DLL. As you can see, the dx command printed all the fields, properties that we can access, and in the next step we are going to create a new function. So that would be load library W that accepts that actually returns a void star, so a pointer or a handle to a module, and that's the relative address that we just found, so the result of running the first command. And then the last one is the procedure length. Of course, that's not really the right value here, but I just wanted to have the minimal, so on 64-bit that would be 8 bytes, so the minimal value to just have this symbol registered. So we will create this function. We can see that now we have additional properties available here, such as parameters, for example, and we are going to use parameters actually to create a parameter for the path, so the file name of our DLL that we are going to inject. And on 64-bit, those parameters are not passed through the stack, so we additionally need to define something called life ranges. Maybe there is a simple way to do that, but I haven't found it. That's how we will match this parameter with the RCX registers. So that's the 64-bit calling convention, that the first parameter goes through this registry. So we'll assign it to this life range. And the last step is that we need to reload kernel base symbols, otherwise the debugger will use the ones which are already loaded, as we loaded them when we tried to resolve the load library W address. So once I run reload /f, then those symbols should be reloaded, and now we can see that we are using the symbol builder symbol. So if I try kernel base then load library W, you can see that it now shows the parameter type for our function. And of course the address here is the same, so we are still at the same relative address. And the last thing before we call this function is that we need to allocate memory for the parameter. So we need to have space for our shell WAPI DLL. So I will use the dvalloc. That's another meta command for allocating space in the debugger. And I will allocate as we are going to use Unicode, we need, let me check, shows that's the DLL we are going to inject, and we can see that its length is 12 bytes. So in Unicode we need to double that, that will be 24, and we also need additional 2 bytes for the 0 sign, for the 0 character. So that makes it 26 bytes. And 26 bytes is 1A in hexadecimal, so we'll allocate this space. Then we'll use this address to put there our name, so the shellwapidl. And oh, I actually skipped the quotes. Let me add them, and we are ready to run the call function. So now we can use call and kernel base load library w, and here we need to put 0x and the address at which we pasted or we put our DL name. Now the debugger prepared everything for our run. We can actually see that the RCX registry is set to this value. I will run only this particular thread, not the whole application. And the debugger prepared the registry and also the call instruction in a way that when it returns, it will create a breakpoint. So if I run it, we can see that shellwapidl was loaded and a breakpoint was triggered. And we can see even that WinDbg showed us information what's the handle to the module. So the result of load library W. And if I now try the list module function again, this module command again, we can see that it's here. So it got loaded, and now we can use this DLL. Actually, we need to use this DLL. We need to find the string copy function in it, and I will use system informer again. So I will double click up.exe, then find the shellwapi, and then here we need to look for the exports. So let's wait, there are a bunch of them, and we'll look for the strcpi function, and relative virtual address is this, and we are going to use this address to this time fix the address that we previously set to 0, because we are replacing the old address, the old import, with this export from shellwapi. So that's the implementation of this function in the new API. So I'm going to use the shellwapi name and then simply add this relative virtual address. Now if I run this command, our address of the import should be okay. So let's see if it got updated. Not 0, but like that, and then we can see that we assigned it to some value, and the application, the test application, is using it. So let's see if now if I press go, we won't see error, but the application will show the correct results, and we can see that there is a hello from, and here's the message box coming from the application, and that's the proper way how this application should execute. Of course, this sort of patching is fine for one-time shots, but it's in no way a permanent solution. So for a permanent solution, you could either edit the import table with a hexadecimal editor or a PEBR, or if modifying the physical file is not an option, perform the updates in memory automatically. And if you are interested, I described the latter way on my blog at lowleveldesign.wordpress.com, presenting also a new tool, Importando, for this purpose. And I hope you enjoyed watching this video, and see you the next time.